Morning. All right, so good morning, everybody. We are going to make a start. Welcome to this month's TechFest. And this month it's going to be all about data. Not this data, a different kind of data that Simon's going to talk about in a few minutes. First, let's get us out of the way. So there's I think there's quite a few regulars in today, which is always great to see. Thank you for the technical support from a couple of them. For anybody that is new to TechFest and is coming to see Simon talk for a second time, our first return offender, as it were. My name is Paul Bailey. I've been helping to run TechFest with Alec now for just over 2 years. And we've had lots of different topics, and we used to be based in our office in Nottingham, out the BJSS offices. But over the last year, we've obviously gone remote. And this has given us the opportunity to perhaps reach out a little bit further than we perhaps would have done. We're hoping to get back into the office at some point, but who knows when that's going to be. Alec, you wanted to do something a bit different in terms of introductions, didn't you? What have you been doing this month, Alec? What's happened in your life? What's been happening in your life?
What's been happening? Well, I moved to a new place, which I've been doing up, which is exciting. I've been hiring for new locations here at BJSS. So, we've got an exciting new Lisbon and Newcastle offices, not just the lovely Nottingham, but still in Nottingham, of course. And actually, exciting news for me personally is I filmed a TV show for Channel 4 about a year ago, and it premieres on Monday next week. So
ooh, what time?
5:30 on Channel 4. I might not be on the first episode though, so I'm telling everyone about this, and I might not be there, but I'm on about half of the series, which is every weeknight for 6 weeks, so quite a lot. So yeah, spot me on TV. It's called Beat the Chef, so it's my side hustle, I think is a popular term these days, which is the food and drink side of things. So yeah, check that out. Send me some abuse on Twitter or social media, and yeah, let me know what people think.
Any famous names there that we can also expect?
Alec Fruscia, number one on the bill. So it's presented by Andy Oliver, who's restaurateur and food presenter. I'm enjoying the Great British Menu at the moment, if anyone's watching that. And then Mark Sargent, who's a Michelin star, works for Gordon Ramsay. Hrishikesh Desai, who was really good on Great British Menu last year, who's got a Michelin star. And then Frederick Forster, and a lady who's the consultant chef at Byron Burgers, the chain. It's more of a sort of fast-paced game show style where they compete to win some money, and then you'll have me making some acerbic comments now and again in the background.
Well, I haven't been doing.
What have you been doing this month?
Anything as exciting that. I kind of feel like I've been set up there. We did actually take on our first employee in New York though, so our Sparky team has kind of grown across the water. Ooh, nice. And that was really cool to kind of spend some time with somebody in the States and find out a little bit more about what it's like to live there and work. So that was pretty exciting. But apart from that, I've been mainly sat in my dining room in front of my laptop.
Nice. I'll go on brand now after.
Hey, go on brand. Now showing off the kitchen.
There we go.
Anyway, today back to the talk. We've got Simon Dale with us today, who I think it must have been about 2 years ago, Simon, 2019. It must have been.
Yeah, it was October, I think.
And I've had the pleasure of working with Simon now for probably about 3 years. And he is a mind of technical information, and I often struggle to keep up with him. But today he's going to demystify data for us and give us some highlights and some cutting edge ways of working. And in particular, one area that I'm really interested about is the whole design ops. And I know he's going to cover that in a little bit more detail. But first, if you've missed a session, we have been sticking some stuff up on YouTube. And we've been doing this now for quite some time. I think we've got a really great talk by Rob Van Tol, which is all about home working, which has got over 205 views. We've got a really more humorous kind of talk from Yvette Kempson, where she talks about how she went from becoming inseminating bulls, I think it was at one point, into becoming a BA, which is a really humorous story. And then Pete Gallagher as well I think he's our second. He's at 156 views, I think, on his history of IoT. And if you've not heard Pete speak before, it's really worth checking them out. And we've got 44 subscribers, which when I worked it out was like a 100% increase on last month, I think.
Oh, what do you think's made that difference? Have you been paying for SEO, Paul? I'm on this budget now.
No, I think we're getting to that curve where it's just going to go like that anytime now.
I didn't mention TechFest on my TV appearance. Channel 4 said it.
Oh,
it was against guidelines to promote.
Did you not wear the T-shirt?
No.
It's just
I didn't have my mug then. Yeah, should have got it in earlier.
We have got a chit chat channel on Tech Nottingham on Slack. So if you do hashtag TechFast #monthly, you can chat there, and Alec will try and monitor as we go through today's session. And we've also got a receptacle giveaway, or mug, as it could also be called. If you want to win one of these delightful mugs, just send a tweet out today to Not TechFest, and at the end of the session, we will pick a lucky winner, and we'll get your address, and we'll make sure that one of these delightful mugs gets sent to you speedily through the post. So there's a few other things happening in and around Nottingham. I think next month there's the Sheffield Digital Festival, and this is a kind of one of those regional week-long festival, which is all around creative industries within and around the Sheffield area. The theme for this year is remote control. I'm not quite sure what that means, but it's definitely, it was really great last year. There was lots of interesting events and experiments and people showcasing work and ways of working. So if you're interested in these kind of things, check that one out. It's really, really good event. And Alec, you wanted to push this a little bit as well.
Indeed, yes. So if you're not familiar with DDD, it's a conference that has a lot of different locations. The East Midlands one is run by Jess, Morton and Rachel, who are all involved, as well as a lot of volunteers and support from elsewhere in the community. It was run not last year because of the situation, but the year before for the first time. Great conference, lots of great speakers. Talking of the speakers, this year it's the last few days to submit a talk. So end of April, which is closed business tomorrow, is the last chance you have, and the talks are selected anonymously by the potential participants. So it's a great way to, if you've got an idea, get it on there. They've also got a lot of support for prospective speakers. So even if you aren't that experienced or not sure, you can submit a short talk, a long talk, and they've got options for everyone. So yeah, check that out. They're on social media, or ask me any questions about it as well. But yeah, have a look at that. And
it's free. It's a free event.
That's right.
It's just fantastic. A lot of effort goes into organising it. I went to the last one. It was brilliant. So yeah, if you do want to speak there, I'd really highly recommend it. Speaking of speaking, if you want to speak at TechFest, are you inspired by Simon's talk today? And get in touch with us. One of the things that we're trying to do is promote the local tech and design community in and around the Nottingham area, and that includes you. So if you've got a burning passion about a particular topic, drop me or Alec a line and get in touch with us, and we can see if we can arrange something. So let's get on to the main event then. So I've got this spiel here, Simon, I'm going to kind of share with everybody. So you're a principal data architect. Is that true?
Yes, that's it.
Principal. What does that mean then? Principal, you mean like you're the top guy?
I don't see it that way. It's a different role. I spend a lot of my time now working with my clients. So it means working with different working different problems, working with different teams, and also looking for those areas of commonality that we can apply to data architecture across BJSS.
That was a very good answer. I was looking for I'm the top guy. Okay, shall we do a switcheroo then? And you can tell us a little bit more about what a Databricks champion is. I'm particularly interested in that.
Okay. Yeah, let's switch screens.
Oh, that just looks good, doesn't it? That slide just looks.
It's some brilliant. PowerPoint's finest stock art. Yeah, brilliant. it's a change from my normal color schemes. I normally go for blues and greens, and now I'm looking at like oranges and things. So
yeah, it brings out your eyes, the orange.
Took a while. Yeah. So yeah, so the talk today is it's about the building bricks of data, which is I can't take any credit for the name. For me, it was the one about MLOps and Azure. So I think our more creative friends, Paul has come up with a great name, and it's a slight pun on Databricks as one of the areas that we're going to be covering today. There is also a focus on machine learning side, which is an area I've been working in more and more over the last 18 months or so. If we move on to the first slide, so yeah, it's the obligatory social media links and a bit about me. So yeah, really since last time I've been talking, I've moved much more into the data world, and I've been working almost exclusively on data projects. So what does that mean, and what makes a data project different? And that's one of the things that I really want to demystify in this, is that data is just different, but it is still software. So a lot of the same problems apply to data that do to normal software engineering. A lot of the same things that you need to get out of the data delivery are also hold true. So yeah, it just means different services, slightly different ways of working, different problems. Scale is obviously one of the most notable things with the whole big data ecosystems and how you work with that. And we use tools like Databricks is one. And while the talk today has an Azure bias, a lot of the principles and things would work with any of the clouds. And Databricks is it's worked on AWS. It moved to Azure. They've also recently announced GCP as well. So it is like a cross-cloud platform as well, which makes it a great choice. Talk a bit about the champion program that Paul mentioned. That's for Databricks partners. So at BJSS, we're a partner with Databricks, and there's a whole syllabus of structured learning and training that you can go through as a champion, and with that you're really acting like a solutions architect for Databricks, but for one of their partners. So yeah, it's really interesting getting access to some of the preview features and seeing what's going to be available to clients in advance as well. That's it. So if we move on, what I'm going to do is start the journey of data, talking about data maturity, because this is really important for organizations, and shown on the right are like 4 different stages that we quite often see, and this is really how an organization views data, how they're consuming data, and almost like the start of their journey towards like AI, ML, and those advanced analytics. So if we look right at the bottom of that curve, we've got data migration to the cloud, and this is often in response to things like a burning platform, a business process that's taking too much time, legacy technology, and things like that. And the cloud is seen as an enabler, as a way of unlocking more value from the data, bringing the data to more people. So that's often the first step that we see with organizations, is let's just get something into the cloud. Once you do that, you then need to start leveraging the benefits of the cloud. If you just move all of your servers into the cloud, it's probably not going to save much money. You haven't really solved the problems of how do you support the systems, how do you handle disaster recovery. You've just done a like-for-like move, and you're just paying somebody else for hosting your servers. You start to see the real benefits when you start to leverage the cloud platforms, the cloud features, and you can start to then identify ways to reduce cost and to improve the quality of your data pipelines. You can change paradigms as well, moving from maybe a data warehouse and looking at a data lake, or the new term at the moment is lakehouse, that combines the benefits of both. And that's really been enabled with the cloud, where you can actually separate the compute costs from your storage costs. I'll show that a bit more on the next slide. Once you've got data, and you've got so reliable, robust data, and you've got cloud services, the next step really is looking at analytics and self-service analytics. it's very much if we bring data, they will come type mantra for the cloud. So look at different data models. Can you put data together? Can you break down the silos and let people integrate and discover new value from the data? And then finally, we move into how we can use AI and ML to really enhance the data experience. And again, there's more on that later on in the talk as well. If we move on to talk about data platforms. So one of the real big benefits for the cloud is that you can define your infrastructure as code. And if you're defining infrastructure as code, you can define templates, and you can get reuse, and you can get scale from that. So if you want to do an experiment, you can very quickly deploy like a sandbox environment where developers and data scientists they can experiment with tools and algorithms. They can experiment with data, and they can use that to actually prove viability early in the life cycle, and that reduces the overall cost of owning like data science. You've got massive scalability in the cloud as well, which is really important, not only for hosting services once they're created, but also in training. Right now, there's a lot of difficulty getting hold of things like graphics cards, Bitcoin, probably AI as well. And graphics cards are really important for actually scaling the training of some sorts of models, so particularly neural networks and deep learning. And having the ability to just lease them on demand when you need them, when you're training data, is really powerful. And again, this is one of the areas that really does reduce cost. If you had to buy top-end graphics cards, top-end servers, and large server farms for training models, then that represents quite an expense. And then going along with this, we've got lots of cloud-native logging and monitoring, which is really important to understand how services are behaving over time. So we said that we'd talk a bit more about like the data analytics, and there's like a value pyramid that looks at what the story that data is telling to you. So right at the bottom of this stack, we've got the descriptive analytics, and this is really just telling you the story of data. So I think of things like dashboards with KPIs on there. Have you hit your sales target? Have you got the right number of customers? How long do customers wait in the queue when they try to contact you? It doesn't really tell you much more than how you're actually doing against those KPI. And it's the diagnostics, which is the next layer in the pyramid that increases the value, because that really digs into the detail. Why are you ahead on sales, or why are you behind on sales? You can look into what channel is being used, what's the most popular channel, what are the most popular products. You can combine other data sources like marketing campaigns, and you can actually see how these all relate to that information. You can also look at things like the customers, how are customers actually responding, how long do they wait in queues. You can dig into the details, and this is the difference with diagnostics over descriptive. So descriptive will tell you if you're on target or if there's a problem. Diagnostic will tell you why it's happening. We then move into the looking forward part of the data. So both diagnostics, descriptive look backwards at data, things that have happened in the past, whereas predictive and prescriptive are looking forward. So what predictions can you make? Will we hit our sales targets next month? And how much revenue are we likely to make? So these are typical problems that AI and machine learning can solve. And yeah, you can do it using like normal statistics as well. If you just plot a curve, how do our sales look, and things like that. But you can also bring in lots of like alternate data sources. You can look at sentiment from social media, and use that to look at our marketing campaigns and things working. Prescriptive is really where you start to hand control over to the algorithms, to the machines. So not only do they tell you that this might happen, but they'll tell you what conditions and what circumstances will allow that to happen. So you see it a lot with things like personalization. So when people interact with your site, you can make recommendations to them. You can suggest different items that they might like to purchase. You can maybe, based on their browsing habits or what they have in a basket, there's an action you can take. Maybe offering them a discount at the right part in their customer journey will help unlock more value. So just trying to think of an example. So if people are buying, let's say, car products quite a lot, and you have relationships with like insurance providers or some of the search engines, maybe releasing an offer at that point will then like trigger additional activity from that customer. And this is really where you use the data that's occurred in the past to train a model that can look forward into the future and can identify those insights. So the next part is, how do we make all of this happen? And a really important vehicle for this is DataOps. So this is really looking at not just the technology and the processes, but it's also looking at the teams and the need for more agility with data. If you're designing the data model to be exactly right, then with the frequency of data becoming more mainstream, the more sources of data, you're never going to get out of the design phase. So you need to adopt agile ways of working with data. You need to look at embracing the DevOps solutions, but also bring from like lean methodology as well, and look at what is the simplest that we can deliver to get end to end with this. Is there one particular like data model and report that we could do for an analytics workload? Is there one experiment that we can prove for data science? So as we move around the circle, we have that define phase where we really need to work with our subject matter experts, our business people, and understand what that problem is. And in the context of machine learning, what is the problem that we need to solve? Because then we move into the sandbox area where we can leverage the platform. We can spin up an environment to explore the data, to analyze, and also this is where we can fail fast, which is a really important concept in machine learning. A lot of what you're doing is data science. So it's science. You're looking at a hypothesis, and some hypotheses you can't actually prove. You can't solve. You may not have the right data. You may not have the right performance. So you need to identify this quickly, and then you can iteratively work with your stakeholders and understand, are there other ways of solving the problem. These two defined in sandbox are really the like the experimental. Are we getting like the right sort of questions, the right sort of answers? And then we move into more traditional. Can we build robust data pipelines to feed data to this to the model? Can we develop reusable code? Can we package it? Can we deploy it? Can we deploy quickly? Can we make sure we've got all of the quality around that deployment through testing? And then we get the orchestration, and here it's really important to understand the lineage of both data and like the model and predictions. So often you need to be able to explain why a model is giving predictions, and there's more on explainability right at the end of the talk, so I'll pick that one up then. And then finally, once you've deployed, you need to monitor. A model is only as good as the data it was trained upon. So over time that will change. So that's one of the really important things to look at. So now we're going to move more into machine learning, and this isn't going to be anywhere near as complicated as the maths on the right. We're just going to touch a little bit onto the different types of algorithms, and also try and illustrate why data science and machine learning is very similar to software. And when you start to actually apply it to real world problems, you really do need to treat it as software as well. So if we look at some algorithm types, there are like three main categories for machine learning. There's the supervised learning, unsupervised learning, and reinforcement learning. So I'll touch on these a little bit. So supervised is when you can present data to an algorithm, and in that data you can give it the answers. So you look at historic data, you look at which customers converted on your website. So you'll have a flag that whether they converted or not, and that's the variable that you want to make a prediction on. You then give it a number of different features about that customer, maybe their demographic, maybe the products that they were purchasing, and then with that you can train a model that will then basically predict whether they will convert or not. And this, like, quite a simple approach really, that you then give that data give new data to the model in the future, and it will then look at the features and work out whether it thinks there'll be a conversion or not. Unsupervised is where you don't really have the answers at the time. So what you're actually doing is looking into the data to identify trends. As we can see on here, there's clustering. Clustering is a great example of unsupervised learning. What you're actually doing is looking at all of the data and trying to identify patterns in that data using an algorithm to do that. So here we simply have the yellow, grey, and orange clusters, but they could represent different customer demographics, and you're identifying what those demographics are. So you could have things like Apple fanboys, the people who are very into high-end Apple tech. That could represent one of those. You could have the the Samsung loyalists, if we're talking about mobile phones that prefer the Android experience, and then that just are looking at their alternatives. So that's examples of clustering. The point is you don't know what those clusters are going to be until you start to explore the data. A lot of natural language processing can also fall into this category. So if you want to do things like topic modeling and understanding different topics that people are talking about in social media or in documents, you can scan all of the documents, understand all of the words, and then look for patterns, repeated patterns in those words and relationships between words to identify clusters. I don't really cover reinforcement learning much in this, but that is often seen where you create the rules for a model and then let it try and find its own way and have rewards for when it gets things right. So this is often used in gaming. So I think the AlphaGo model is a great example of reinforcement learning, where it was given the rules and rewards for that as well. So as we look at the different types, these are really solutions to different types of problems, and these are probably the three most popular. So we've covered clustering quite a bit. So I'll jump onto classification next. So classification is really what type of thing something is. So it can be as simple as yes, no. You've got two different classifications. Is a customer going to convert or not? But you can also have things like what type of an object is something. And here what you're really doing is you're giving the algorithm a set of different categories, and when you train it, and it will then try and find a way of getting to a particular category with the data. The little diagram shown here represents a decision tree, where all of the yellow circles represent individual decisions based on the features, and the orange circles, they represent an outcome. They aren't necessarily discrete outcomes. You could have so out of the 9 different points at the bottom, you may only have 3 different discrete categories. It's just the path through the tree and how it arrives there. And that can be as simple as, again, if you look at different customer demographics and age, if age is one of those, the first thing could just represent maybe under 30s, under 65s, and over 65s could just be 3 decisions which get made by the algorithm. Regression itself is where you want to predict a numeric value. Typically it is. You also have things like logistic regression, which is looking at yes, no's as well. But yeah, in this case, what we're actually doing is we're fitting a line to the data that we can see, and then from that we can identify where on that line we would be with a particular prediction, and we can identify a value from that. So there's a little bit of maths here as I try to represent traditional software development as a function. So it really doesn't matter what paradigm you're using for developing code, whether it's object-oriented, functional, or procedural. Your function is a number of different steps. So you're coding an algorithm up front, and it may be a case of take a product ID that's supplied as a parameter, add it to an order, calculate the new value for that order, and return that value to the end user. It may be placing the order, and it may be returning a new product count or something like that. But what you're actually doing is you're designing and coding that algorithm up front. that code is static once you've compiled it. So you know exactly what it's going to do. The parameters that then get provided to that function, and they generate the output. So if you want to think of like machine learning as, so you've got different stages for machine learning, but what we want to try and do is express it in the same way as software development, so we can see the similarities. So if we look at training a model, then the outcome that we really want is a model that is trained that we can use for predictions. And in order to get there, we have an algorithm. We use one of these predetermined algorithms, whether it's clustering, so k-means as an example, whether it's a categorization, whether it's classification, whether it's a decision tree or something else, or if you're looking at regression, is it one of the linear regression type models? It may be a neural net if there's a more complicated problem, so things like image recognition fit there as well. But what you're really doing is you're providing it mostly with features and labels. So again, assuming a supervised learning where you can actually provide the labels to it. And then when you execute this, when you train all of that data together, the output from that is a model. So during the training stage, you're providing it with both the data that you expect to see and also what the answers have been in the past. The training process is going to look at lots of different combinations of things like hyperparameters and weights for particular variables and things like that, and run through a number of different combinations. And then the result is going to be you get a model that has been optimized for a particular scenario. And this is where you really need to work with the business stakeholders and understand what the different sensitivities for the model are. I'll talk a bit more about that under the explainability section later on. So once we've trained our model and we want to actually make inferences against data, you can see this is looking very similar to that first software engineering expression. So your output Y is now a result of the model, of calling the model as a function. So it's prediction, and you pass in the data. So here, all we're really doing is replacing that hand-coded function with a model that's been trained. The big difference is you don't necessarily know exactly what's going on in the model. You know that you've created a model, you know that you've optimized it for your particular data set, and you know where it's going to you know some of the conditions about how it's going to behave with certain data sets, but what you don't know is how it's going to behave with data it's never seen before. So there's a lot of training and validation that has to happen before you can just use a model with live data. And then there's the constant monitoring that you need to do to see how it is performing as you move forward. So I've spoken about features a lot, so it's also worth talking a little bit more about what makes a feature. So on the left here, we can talk about measurements, metrics, and features. So a measurement is a numerical observation. So if you think of how busy a computer is, you can look at CPU percentage. So maybe you have a number in it, let's say 40%. A metric is actually applying like a standard to that. So CPU measurement. So 40 now changes from just a number of 40, it changes into 40%, or maybe it's 0.4. And you're looking at that and it tells you something about the environment you're in. You know that how that relates, how you can compare that to other things. But a feature is looking at your entire sample of data. So what you might want to do is also take into account the number of cores so that you can actually have like a normalized value. So a feature is individual and independent. So maybe if you just want to express how busy a computer is at a particular point in time, in order to make that an independent value, you need to include how many cores there are. Maybe they're two separate features, but you may want to combine the two into one so that you can actually compare the different numbers more easily. There are probably lots of other features, other categories in that example that you'd also need to include as well, like the type of CPU and the instruction set, etc. If you're looking at a model that predicts performance, it's just it's to try and illustrate that numbers on their own without context don't have meaning. But in terms of machine learning, you actually need to look at how those numbers relate to an entire population of data. There's also the concept of online and offline features, which is quite important as well. And if we look at the diagram below, what that's trying to show is that when you're doing your exploration and development, you're probably working with offline data. It's data that you've accumulated over time. You could have it saved in your data lake, and it's not currently moving very quickly. Whereas if you've got a model that's deployed into production, the data for that might be moving very quickly if it's based on things like clickstream advertising and things like that. So we need to be able to get pre-calculate the features so that when the model's invoked, you can get that sub-second latency. So feature store's a way of cataloging and identifying features, promoting reuse, and allowing and giving you consistency if you need to impute values. So imputation is when you have a value missing. How do you fill in that missing value? Because a lot of machine learning ends up with multiplication, just setting the value to 0 to represent it's missing isn't always a good outcome. Choosing the average might be better. So it's really understanding what's right for each feature, and then documenting that in a way that can be searched. The feature store concept gives developers one view of features, and it abstracts how that feature is actually being persisted and stored. So now we're going to move on to productionizing machine learning and how we actually take the theory and we can then deploy that in practice. So before we get there, I'm going to put up some really scary numbers. So 85% of big data projects fail is something that was found from a Gartner report. So they originally predicted 60% of all big data projects fail. But one of our analysts, Nick Hoydecker, he later revised this up to 85%. And he found that it isn't the tech that's the problem. A lot of the time, it's the difficulty is integrating with existing processes, that you have internal resistance or politics, or that there's a lack of skills and also problems with security and governance around using big data. That's often one of the challenges that we face working with that is, it's a great idea to put all of your data together, but once that data is together, all of a sudden it's a very attractive target for hackers if there's a way to get that data. And there are also different data sets that you can blend together that on their own are quite innocuous, but when you put them together, they can either reveal more information about users or sensitive information about your company that you may not necessarily want people to link together. But again, the way to make your data project succeed is to build small. So look at what's the smallest thing that we can build, and almost take a bottom-up approach and let developers kind of lead that delivery as well. VentureBeat, they looked at data science projects, and they found that 87% never make it into production. And again, very, very similar types of issues of highly siloed and teams not communicating with each other. So data scientists who can't get access to data because it's locked away in different silos, the different formats of data and being stored in different places. And then lack of collaboration between data scientists, data stewards, DevOps and engineering. They found that if data scientists only work in notebooks and then they throw that over the wall to an engineering team, it often met with more problems in turning it into a production solution. And again, the advice was to start simple, prove the complexity, and then find the right way of blending cross-functional teams to deliver. Which is what I'm going to show on the next few slides. So here we're looking at a process of delivering machine learning, or MLOps, if you like. And it's been divided into the same 6 categories shown earlier in DataOps. So where we define that problem. And if I highlight those now. So this is what I'm classing as that traditional data science. So we're working with a notebook, we've got hold of data, and we're looking at what insights we can actually find in the data, doing some visualizations in those notebooks, and just really experimenting, can we prove that value? The reason it's important to have everything else that isn't currently shaded is when you think of if you've found that there's value in the data science you're doing, you really need to think about what's the business process that's going to wrap this. If you are the business process, that you're the data scientist, you're doing all of your data preparation, you're extracting your features, you're training the model, you're executing the model, and you're then giving somebody a report. You have turned yourself into that business process. So the next month when they want the same report running to look at the next month's sales figures, they're going to come knocking. They're going to be asking you, can you please just run that report? And what you really want to do as a data scientist is you really want to focus on data science, the value. How do I actually add value and create new value for the business? And you can't do that if you are a legacy BAU system. So it's really important to then unlock that data science that you found. And we can really do that with the area that's shaded here. So by treating your machine learning as software and understanding that you've actually developed new data pipelines for extracting features, that you've developed model code that you need to version, that you need to track how it's changing, you can then see a lot of commonality here with standard software development, where you have source code, you have CI/CD pipelines, you have validation and testing, and deployment to end users. Some of the differences here are that your deployment involves training the model rather than necessarily just installing some software somewhere. And you may not know exactly what that model is doing when it's trained. You know the generalization, you know how to generalize that model as well. So again, more explainability later. But what you want to do is you want to add in this the concept of a model registry, so you can actually track every model that you've ever trained, how it's performed. Is it actually better than the previous one? And you can then actually make decisions about, do we release this model into production or not? Do we need to do a new training run? Do we need to choose different hyperparameters and things? So again, you've got lots of iteration on here as we go. Once the model is being served, then it's really important to know that your data validation has passed before it gets there. That you can validate any of the predictions that you're serving. And this is where things like model drift and data drift really come in as well. We need to have a look at, are the predictions being served by the model representative of the predictions it saw when it was being trained, so that you can have confidence that what's being predicted is still accurate. And data drift is, you're often building a model because you want to change some behavior of your, let's say, customers. For an example, if you've identified that you're weak at selling to the under 30 demographic, you may come up with a marketing campaign to target them, and your data will show a lack of sales in that particular demographic to start with. Assuming your model's successful and you drive more sales from that demographic, that gap will start to disappear, and your data distribution will then start to change. So you probably then need to identify this and retrain a model that can better target based on the new data that you've now made available. And this is really where the feedback loop gets closed, is that you have a framework that can identify model and data drift, understand its severity, and it can then trigger a notification. So this can either be an automatic retraining of the model through the CI/CD pipeline, or it can be like an alert through a backlog. You can raise items saying that more investigation is needed. So if we move on, we can actually look at what the MLOps pipelines look like and some of the technology that you can use for this. So some of the keys for MLOps pipelines are enabling that collaboration between data scientists and also machine learning engineers or engineers who are going to be releasing and maintaining the code. Ideally, you want this to be a single team, but you have the different roles within the team. Having this automated flow of models to production is really good because it allows fast iteration and then being able to track the different models. So if we just take a journey around, we can actually see here, if we focus on the different teams, you have teams who are developing, and we need to bring them together for collaboration. And an MLOps culture really promotes this. We're looking at promoting automation, reducing the cycle time, how long it actually takes to iterate, and to eliminate waste. And it's really important here to actually meet the teams where they are when you first start working with them. You can't just come in and impose a new tech stack on a team. So adopting things like development in notebooks is really important. They definitely have a place in data science, even though they may not be the best vehicle for a production model. And that's where you can bring in expertise from machine learning engineers to look at how to refactor that code, how to apply good principles and design patterns to it and create reusable libraries that be deployed. As we move on, as with most CI/CD pipelines, you're looking to produce a single artifact that you can then use in different environments. And this is really the model training that you're going to go through. Data science needs to work on production data, but it doesn't mean that you have to serve that model immediately to production users. You can put it through different stages, and both Databricks and MLflow are really good at that. Other solutions like AWS's SageMaker or Azure's ML Service are also good at providing the same functionality, but here we're talking about Databricks. And the differences between environments then become configuration, and you can securely store that in your CI/CD pipelines so that you can promote models between different like environments or stages. And that gives you all of the other benefits that CI/CD does with like accountability, traceability, and approval gates as well. So once you've created models with Databricks as part of the training, you want to register those with a service like MLflow. This is like the model registry in this case. And what you're doing is you're tracking every experiment, every run, all of the parameters, hyperparameters that you've used, different models, if you like as well. You may be trying regression and classification together to look at which one's going to give you the best outcome. So logistic regression, decision tree, for example, or maybe a neural network as well. And all of those, as you validate the models, you're going to have a number of different metrics produced about it. You can look at things like confusion matrices and rates of sensitivity or recall, and all of those you would log in the model as well, because that's going to aid making that decision about which model is best. Are you better than the model that came before? It's also great at providing a standard format. So a lot of models have a fit method for training and a predict method for serving results. And MLflow will just wrap this, and it means that you can have a standard interface into all of your models, which is really important. So you can fit these models into different processes, whether it's a batch process, streaming, or real time. There's more on that on the next slide. So as you're doing the training, you really want to track your performance against various different metrics. So this is the model drift and data drift that we spoke of in the previous section. And you really want to be able to understand how that behavior of a model's training and make necessary alerts. So here we show a link back to the backlog. There could also be a link back to the CI/CD pipeline to trigger a new build if necessary too. And also, as with all CI/CD pipelines, it gives you this brilliant view of lineage and ability to track a model. Not only can you look at like the backlog through to like the code that's being worked on through to the model that's being built through to deployment, you can also go back again. You can look at what versions in production, how was it trained, what hyperparameters were selected, how did it, any visualization that you want to capture and archive as well. But you can also look at the code, what code changes were made, who made the code changes, and what storage were used for that. There's also the approval as well, which is really important in regulated industries. So that's MLOps pipelines. And as I said, we're going to talk about model hosting a little bit as well. So once you've created a model, it really is important to now think of it as code. And often models are made available as Docker containers for portability. MLflow as well gives you a degree of portability in that you can load the model. You can track all of its dependencies and runtimes that you need in order to get it up and running. So here we can actually host it. I've shown two different runtimes for hosting. So one is to feed it back into Databricks, which is brilliant if you're processing like static data from your data lake, or if you're using structured streaming on data. Where you're actually building a data pipeline, you can feed the model in its native form, and you can scalably execute that against data. And that could be used for providing analytics to users through Power BI. Other examples, maybe you have users on the website who are expecting on-site personalization. So as they interact with your site, you want to make recommendations, you want to provide like next best actions and things as well. And here they'll be interacting through an API. So you could host the models in systems like Kubernetes. You could take in streaming data and return very quickly. And this is where you'd probably be looking at one of the online feature stores that we spoke of earlier. And then the other use case shown in the middle is real-time data, whether it's IoT, whether it's social media, things like that. And again, you can use an event hub to like stream that data in Azure, either using structured streaming in Databricks, or you could use functions through Kubernetes and just persist the data straight to a data lake as well. And then key to all of this is monitoring those models, as we keep mentioning, to understanding whether there's data drift, model drift, or if there are any system performance issues that you need to act upon. So coming to the end, because I realise time's moving on quickly. So we can look at model explainability. So quite often models are seen as black boxes. So once you've trained it, you don't know exactly what's happening. And there are lots of libraries that can help with this. So popular ones are things like SHAP. There's InterpretML and FairLearn, and there's some links on the next page for these as well. But really, explainability is about understanding what criteria are being used to by a model for making a decision, and it gives a human a degree of interpretability of a model. So this is really important when you start looking at ethical and responsible machine learning development. So making sure that certain protected features aren't used to make decisions that can adversely affect outcomes. So an example that's often used in talks around ethics is gender on loans. There's a data set that's used quite a lot for that. And if the only feature that determines if somebody receives a loan is gender, then that's introducing bias on a protected feature. So you need to be able to identify that during model development and ideally eliminate bias from the model. A great example that really shows explainability is the image here. So it's an algorithm that's classifying whether a picture is a husky or a wolf. And there are two which didn't get a prediction right. So the second from the left on the bottom row and second from the right on the bottom row were both miscategorized. And it's really interesting reading through, because there were a number of different people were asked during the experiment as to why they thought there were differences, and only half of them started to get the answer right. And you can look and go, well, they do look quite similar. Huskies are a little bit lighter in fur. Maybe that's it. Maybe their ears are a little bit more pointy, but that isn't what happened. If you look at the images, every image that has got an accurately predicted wolf has got snow in the background, and everyone with a husky doesn't. So in this instance, the model was predicting is there snow in the background, and it wasn't predicting is this a wolf or a husky at all. It just so happened to be accurate for like 80% of the time. So again, understanding how models are behaving, are they giving you the results you want because of the features that you're expecting is really important. So I'm going to move on now to a slide with some resources. So here I've put together more about MLOps, which is a great article from Google. A number of tools and libraries for the explainability, so FairLearn, InterpretML, and SHAP as well. And then there's some training around Databricks and data engineering and data science using Databricks as well. So these are two Microsoft provided pathways that can be used. And yeah, that brings us to the end of the talk.
Woo! That was amazing. my brain is blown. There's so much, you've crammed so much stuff into there, Simon. Thank you very much. So we're going to open, if people are still okay to hang around for it, we're going to open for a few questions. I've got a question about the whole ethics thing, like the kind of the explainability. You know, how do you, if you create this kind of model, is there a danger that you're not going to know how it figures things out? How do you deconstruct it?
Exactly. And I think if I can just go back, algorithms like, packages like CHAP are really good at looking into these. So the model on the right would have been a neural network, and it would have had a number of different layers in there. So what you can do is you can actually decompose that network. You can look at each of the different layers, and you can look at, in the case of an image, you can highlight the pixels that are actually making the most impact on that particular layer, and you can trace through that image to understand how that's impacting the outcome. Again, if your model is using a decision tree, you can look at what are the different stages in that decision, and you can look at understanding feature importance. I didn't do too much about ethics because that's a topic on its own that could easily have taken just as long as this one has.
We've got another question from Josh. Josh, if I allow you to speak, do you want to ask Simon your question? So Josh, you can now speak and be heard.
Sure. Can you hear me?
Yes, we can.
Yes,
excellent. Thanks very much, Simon. Really interesting talk. My question was, a lot of the companies, particularly companies who are wanting to get into machine learning and AI for the first time, they have a lot of these tools really heavily locked down. So even things like getting anywhere near Azure, there are 100 loops to get through, and you have to give a very specific request, and then in a month's time, you might get access to it.
Yes.
How do you, with the kind of models you've shown today, how do you get around these limitations in a pre-established company, especially when you're dealing with anything near production, which is even more heavily locked down? And how do you get around these limitations, especially without requiring their current software team and their current DevOps team to spend 50% of their time learning all of these new toolings?
I think that is one of the big challenges is that skills gap. So when we've worked with clients, we've made sure that like knowledge transfer is as important as part of the deliverable as the actual end result, so the model itself. So a lot is it's not the technology. So the technology will definitely support secure ways of working. So in Azure, a lot of these services now support private network communications only. So things like CRML service, Azure Synapse, Databricks, there's all private link capability in there. So you can just link them to your network and keep them locked down. A lot of the problem is going through the governance, going through the process, going through architecture, and giving them confidence that is indeed the case. And one of my colleagues, one of Paul's colleagues as well from our Spark team, has worked on a fairly large data platform in the public sector. And the way we addressed it there is we looked at data as a service. So we were looking at identifying all of the different personas, all of the different stakeholders who had an interest. And we were looking at mapping out different services for how the business will engage with the data platform. And then from there, you can you can start to build out ways of deploying infrastructure that meet the right security concerns, that have the right level of lockdown. So a lot of the time, it's about making sure that you can dock into existing business processes. So one of the things that Databricks does really well is integrating with an Azure Active Directory if you're in Azure, to the point that you can configure which groups should have access, what levels of access they should have, not only to Databricks, but also to things like the data lake and accessing particular files. And then you can dock into the existing like user onboarding services that a business might have. So they would put in a request, please could I be a member of this new group? And then that will enable them in things like Databricks. It will grant them access to certain data sets that they can have access to. So I'd really look at what are the benefits that the platform can provide, and to build services that support it. But yes, if an enterprise isn't already there, it is always a challenge to help with those ways of thinking. But it's always, I always find it's better to have a unified tool like a CRML service or Azure Databricks that people can develop within, than the alternative, which is that they take copies of your production data onto laptops and develop offline. That's even harder from a governance point of view, to know who's got what data and where. So I think, yeah, it's a shift in governance. Is it is it just the governance of we're controlling people having access to data, or is it we're going to allow people to have access, but we're going to control like the scope of what they get access to and the tooling that gives them that access? Has that answered the question for you?
No, apparently not.
We're running over time a little bit, so if anybody else has got a question, if you want to fire it in now.
So if I fault Paul with our waffle at the start, I shouldn't have been talking about TV shows for 10 minutes. Sorry, Simon.
All right, we're coming on to 10 past, but Simon, I want to thank you very much, because obviously lots and lots of effort gone into this. It's a really, really great talk, and it's really opened my eyes to how some of this stuff works, because I don't know, from a kind of outside perspective, it all seems very mysterious and kind of black box magic tricks.
Yeah, that's one of the things I really wanted to highlight, is that even though there is a lot of mathematics involved in choosing the algorithms, and that's really the value the data scientists bring. When you're thinking of applying data science to a particular problem, there's a lot of it is software engineering. So what you'll actually find is that you've already got a lot of the skills necessary for doing it, in terms of building pipelines, being able to monitor a live service, and things like that. And it's about making sure that the teams, so thinking as a team rather than an individual, that the team is enabled to take on all of that responsibility, so that you have a data scientist working with your developers who can then build that robust software, with your platform engineers who can then deploy it, and ultimately the team can then own it and run it as a service. And that's really the key that the slide with the two big scary numbers on was making, is that it's not technology, it's the process, and it's the collaboration that is key to making it successful.
Great.
We did have a comment that I'll leave you with that was on Slack. Apart from the positive comments about the talk, Simon, and someone said, "Oh, I'm going off to my data project to work on that now. That has an 87% chance of failure. So motivated for the day ahead," which I thought was.
I didn't write that report.
Oh dear. Right. So shall we wrap up, Alec? We got anything?
Yeah.
Yeah. Well. Okay. Well, thank you very much, everybody. It's really great to see you, and thank you especially to Simon. Join us again next month, where we'll have another exciting speaker. But go away and have a great day, and hopefully make your data project a successful one. All right.
Next time.
Take care, everybody.
Thank you.
See you all later. Bye.